Hi, Math 20-1 students. So we are carrying on with the concept of multiplying and dividing rational expressions today. So in our last lesson, we looked at kind of the basics of multiplying and dividing. And today we're going to combine those two operations into kind of like more complex type questions, including word problems. So in the first one here, we're going to look at simplifying this whole long operation. And of course, as always, we need to determine the non-permissible values. So before we do any multiplication or division, we always want to factor each numerator and denominator, just like we've been doing up until now. So for this top one here, if we factor that 3x plus 12, we can pull out 3 is common to both of those. So x plus 3 times 4 would give us 12. On the bottom here, a little bit more complex because we have a quadratic function. So we want to use the swing method here. At least I do. So I'm going to do that. So remember, that's just multiplying the 3 by the last term here. Actually, I'm not going to put this here because I feel like it's going to get in the way of what I'm going to be trying to do over there. So I'm just going to kind of put it out over here. Actually, then I won't be able to show you the work down. Okay, I'm just going to work up here. This is going to be a bit of a messy page. Sorry, guys. So I'm going to have x squared minus 5x. And then I'm going to swing that 3 over 3 times by negative 12 gives me negative 36. Now to factor this, two numbers that multiply to 36, negative 36 and add to negative 5 would be negative 9 and positive 4. So negative 9 plus 4 will give us negative 5. Negative 9 times 4 will give us negative 36. So x minus 9, x plus 5. And then we want to divide out that 3 that we used to multiply. So I'm just going to fill in my factored form down here. So x minus 9 divided by 3 is 3, so we can keep that as x minus 3. Now for this one, 5 doesn't divide evenly into 3, so we want to swing the 3 up to 3x plus 5. So there's our factored form for this first one. The next one, we have 12 over 3x plus 4. We can't factor anything out of there, really. So that means all we have to do is, if we wanted to, we could already think about flipping this. So because we're dividing, we want to flip it to multiply. So let's multiply by moving 3x plus 4 on the top and 12 on the bottom. And then for this last one, can we factor anything out? 2x minus 6, we can factor a 2 out of there, so that we are left with x minus 3. And then on the bottom, x plus 4, we can't factor anything out of there either. Now we have everything set up to multiply across, so we just want to see if we can cancel any common terms. I'm just going to see if I can find my highlighter. There we go. Hold on a second here. I thought I had 3x plus 4. X minus 3, 3x plus. I think I made a mistake here because I'm looking at these two and thinking that they should probably be the same. Oh, because it should have been 9 times 4 is 36, not 9 times 5. There we go. So it should have been x plus 4, 3x plus 4. There we go. That makes more sense. That's the nice thing, is when you're looking for common factors, you can always, like a lot of times, you can catch if you made a mistake in your steps there. So 3x plus 4 is going to cancel out. X plus 4 and x plus 4 are going to cancel out. X minus 3 and x minus 3 are going to cancel out. And so we are left with, on the top, 3 times by 2, which gives us 6. And on the bottom, we just have the 12. And of course, reducing that to simplest terms, 6 goes into 6 once and into 12 twice. So 1 over 2 is our simplified version of that. Then we want to determine our non-permissible values. So remember, we have to check the denominators at all stages. So in this first one here, we had x minus 3, so we know that x cannot equal positive 3. We had 3x plus 4, so remember, basically you just take this number and divide it by that number, but we have to do the opposite, so it's going to be negative 4/3. In this one we had 12, but keep in mind that we flipped the original one here. So this was actually originally a denominator, so we also need to account for that in our non-permissible values. Now because it's the same as this one, we still end up with negative 4/3. And then our last one over here, we didn't flip it, so all we need to check is this. And we would need x to be negative 4 there for it to be adding up to 0. So there's our 3 non-permissible values for that expression. Okay, so you have an opportunity to try doing your own here. So if you want, you can pause the video. The answer is at the bottom, including the non-permissible values. All right, let's try one more and then we're going to do a word problem, and that's actually it for today. So a nice quick lesson. To simplify, what are the non-permissible values? First of all, looking at this first one here, we have, if we factor that, you can see it's a perfect square because x squared square roots to x, 16 square roots to 4, and y squared square roots to y. So, but remember, with a perfect square, you need to do the same bracket but with opposite operations. So x plus 4y. And then we want to divide that by, can we factor this one down? A little bit of a different situation here. We have the only common value for all of these terms is x. So if we pull x out, x squared divided by x is x. 2xy divided by x is 2y. Okay, then we want to multiply it by x squared minus 4xy. So again, 4xy isn't a perfect square because of the xy in there. So all we can do for this one is factor out the x. X squared divided by x is x. And 4xy divided by x is 4y. And then this one, x squared, little bit tricky because we're throwing in an extra variable there, but we still think about the same concept. So we don't have an a value here, which is nice. We don't have to use the swing method, but we need to think, what are two values that multiply to make 8y squared and add to make negative 6xy? It's a little, I guess it's a little tricky because the x you don't really think about. I would just say two numbers that add to 8, multiply to 8 and add to 6. So I would say negative 4 times by negative 2 will give me 8, and negative 4 plus negative 2 will give me negative 6. And if I have negative 4y and negative 2y, they're going to multiply to 8y squared. The x is going to come from when you multiply through the brackets. So basically what I would have is x minus, we said minus 4 and minus 2 to add to negative 6. So minus 4y. And then x minus 2y. And if you weren't totally sure about that, I can show you really quickly. If we multiply that out again, you would end up with x times by x is x squared. X times by negative 2y is negative 2xy. Negative 4y times by x is negative 4xy. And negative 4 times negative 2 is positive 8, and y times y is y squared. So if we combine that, it's going to be x squared minus negative 2 minus 4 is minus 6, and we're combining them because they're like terms with the xy, plus 8y squared. So you see we end up with this same thing here. So if you have that extra variable in there, follow the same process where you're still looking for two numbers that multiply to this, but just be aware that the x is coming from the multiplying through the brackets, so you're only looking for two numbers that would add, like the two numbers you come up with for here, the negative 4y and the negative 2y, just think about them minus this x for the addition component, essentially. Okay, so a little bit more complex, but not too bad. Okay, and then we're dividing by this last one. So if we probably want to actually just multiply by the reciprocal. So let's try factor this one before we bring it down. X squared plus 4xy. Again, the common term here is x, so let's pull that out. X squared divided by x is x, and then plus 4y, right, if we pull that x out. And then we have x minus 2y can't be factored anymore. So this is the expression as it's set up now. We want to flip it so that we can multiply instead of divide. So x minus 2y needs to go on the top, and our denominator will be x plus 4y. Okay, so here's our whole expression. Now we want to cancel out like terms. Okay, so x minus 4y, actually I'll grab my highlighter for this so it doesn't get confusing. X minus 4y, x minus 4y. X minus 2y, x minus 2y. There is an x minus 2y here, but we've already used them. X plus 4y, x plus 4y. And we also have just a single x being multiplied here and there, so we could cancel those two out. We still have that one there, but that's okay. So now what we're left with is, on the top, the only thing we have is the x minus 4y. And on the bottom, we have x minus 2y here and x there. So we have x minus 2y. Okay, so there's our simplified statement, or simplified expression rather, sorry. And then we just need to solve for our NPVs. So with NPVs, it's going to be x cannot equal. Let's see, in the first one, we factored this one to be x times by something, so that always means we have to include 0 as an NPV. Now in this one, a little bit trickier, right? What do we say our x cannot be? We need to set this equal to 0, so x minus 2y cannot equal 0, and then we need to isolate x. So in order to do that, we need to add 2y to both sides, so it would be x cannot equal 2y. Okay, so 2y is one of our NPVs. We have the same thing here, x minus 4y, so that's going to be x cannot equal, right, same exact math here, so x cannot equal 4y. Then we have x minus 2y again, so we have already kind of dealt with that there. We have x plus 4y. So if we had minus 2y, then we would say x cannot equal 4y. But if we have x plus 4y, x cannot equal negative 4y. So we can say plus minus 4y for this NPV. It can't equal positive 4y or negative 4y. Then the last thing we just want to double check is, because we flipped this statement, so we accounted for this non-permissible value, but we also need to remember the original denominator, which was x minus 2y, which we've looked at these ones already and determined that that was positive 2y. That would not be permissible. So we have dealt with all of our denominators, and so those are all of our NPVs. Okay, last component here is a word problem. So getting into even more complex types of questions, but we're basically still doing the exact same math, right? So this one says fog can be cleared from airports, highways, and harbors using fog dissipating materials. One device for fog dissipation launches canisters of dry ice to a height defined by this expression, v squared sine x over 2g, where v is the exit velocity of the canister, x is the angle of elevation, and g is the acceleration due to gravity. What height can be achieved if v is equal to this expression in meters per second, and x, so the angle of elevation, is 30 degrees. So the first thing we want to do is substitute in our value that's replacing the v here. So if we had v squared here, and now it's x plus 3 over x minus 5. we want to square it because it's v squared. Then that's being multiplied by sine 30. Sine 30 degrees. And we're dividing it by 2g. Okay. Now the next thing we can do is see if there's a kind of like a good number value or what's the word, exact value for the sine 30. So if you put sine 30 in your calculator, you'll find that you end up with the value of 0.5, which we could write as a fraction to keep things easy since we're dealing with, fractions and rational expressions. So that would make it into, let's keep this the same. So we'll have x plus 3 over x minus 5 squared. And it's being multiplied by sine 30, which is a half, so multiplied by 1 over 2. Now the other thing we can do here to simplify is because we have kind of like a fraction over a fraction, this is the same as saying take all of this and multiplying it by 1 over 2g. Right, and that's going to allow us to kind of simplify this a little bit more so that we have separated this out so we don't have a fraction over a fraction. So now if we say, because we would multiply this straight through, right, and it'd be, if we multiply this through by 1, it would still be this squared over 2g. So that's how you can kind of confirm that that was accurate to rearrange it like that. So now that we have all of this set up, we want to see if we can simplify this at all. So basically, let's see, what does that mean? We're going to have x plus 3 on the top, and it's squared. Okay, so now we just want to multiply through the fractions the way we've been doing all along. X plus 3 is squared, times by 1, so we don't have to change that because multiplying by 1 doesn't change anything. On the bottom we had x minus 5, but this whole expression was squared, so we need to square that, times by 2 times by 2g, so 2 times 2 is 4g. Now normally if we had something written like this, we would put it down as x plus 3 squared. Usually we just put this outside the bracket, right? So we would write it as 4g x minus 5 squared. Okay. We don't have any common factors here that we can cancel out, so that means that we're basically at the end of simplifying our expression. And so because this is a word problem in a test, you would just want to say the height that can be achieved is represented by the expression x plus 3 squared over 4g times by x minus 5 squared. Okay, so with the word problems, just keeping in mind, like, don't get too thrown off by all the extra information. Just really think about what the math is that they're asking you to do. In this case, it's substituting in and kind of trying to simplify. Some of them are fairly complex, so I've given you some questions to try out of the textbook, and I've allowed you to choose 2 from 9 to 12 and 2 from 14 to 18. However, with a shorter lesson today, you might want to try more than 2 from each section because the more practice that you get, of course, the more you'll start to understand some of the kind of like little tricks and things like that with dealing with these word problems. All right, so that's everything for today, and the next time we're going to move into adding and subtracting rational expressions. So I will see you in that lesson.